Okay, good evening, students. Today we will learn the difference between machine learning and statistical analysis. The advent of advanced computational technologies and the proliferation of large datasets have led to the development of two distinct approaches to data analysis, that is, machine learning and statistical data analysis. While both methods share the common goal of extracting insights from data, they differ significantly in their underlying philosophies, methodologies, and applications. This part is very, very important. Now, we have to understand what is called statistical analysis. Statistical data analysis, also known as traditional statistics, is a well-established field that focuses on inference and hypothesis testing. So in case of the statistical data analysis, you have to think about the hypothesis. That is whether the two groups are significantly different or not. Its primary objective is to identify patterns and relationships within a dataset by applying statistical models and techniques. Statistical analysis typically involves formulating hypotheses and research questions, collecting and cleaning data, because when you collect the data, then you will find a lot of the missing data. So you have to clean those data. Even you may get some outlier in your data, and you have to clean that data also. Next is applying statistical model. That is the regression to analyze the data. So regression we use for prediction purpose, and ANOVA we use to maximize between group difference and minimize the within group difference. Interpreting results and drawing conclusions. So this is the main purpose. Statistical data analysis relies heavily on probability theory, mathematical modeling, and the assumption of a underlying distribution of the data. You have the specific assumption about the data, that is, your data will follow the normal distribution. So that is your basic assumption. And it is widely used in various fields, including medicine, social sciences, and business. So statistical data analysis has wide application. Okay, so initially it starts with the specific hypothesis. Now I am coming to the machine learning. Machine learning, on the other hand, is a subfield of artificial intelligence that focuses on developing algorithms and statistical models that enable computers to learn from data without being explicitly programmed. This part is vital. I repeat, machine learning is a subfield of artificial intelligence that focuses on developing algorithms and statistical models. So the researcher has given the specific algorithm and the statistical models to the machine, and machine will follow those all algorithms. Here machine means the computer, so that computers will be able to learn from the data without being explicitly programmed. Usually in statistical data analysis, we collect the data and next we categorize the data based upon certain assumption. But in machine learning, this categorization will be made by the machine himself. Machine learning algorithms can be broadly classified into two categories. Supervised learning, that is the regression classification. Supervised learning means when there is a level based upon certain assumption, maybe based upon the theoretical assumption or maybe by the statistical models. For example, regression. So in case of the regression, you know which are your predicting variable and which are your predicted variable. Classification. Again, you know which are your independent variables and which are your dependent variables. And unsupervised learning. In case of the unsupervised learning, you do not have any label initial. But in case of the supervised learning, you have the label. Machine learning has become increasingly popular in recent years with applications in areas such as natural language processing, computer vision, and recommended systems. Key differences. Number one is the goals. Statistical data analysis aims to identify patterns and relationships, while machine learning focuses on developing predictive models. So, in case of the statistical analysis, you are dealing with the correlation mainly, but in machine learning, machine will do the regression. Number two is the methodology. Statistical analysis relies on mathematical modeling and hypothesis testing, whereas machine learning employs algorithm algorithmic approaches, and iterative training. Assumptions. Statistical analysis assumes an underlying distribution of the data, whereas machine learning makes minimal assumptions about the data distribution. Scalability. Machine learning is better suited for handling large, complex data sets, while statistical analysis can become computationally intensive with large data set. When your data set is very, very complex and when your data is very large, then you can apply the machine learning. But the statistical analysis can become computationally intensive with large data set. So machine learning can handle the big data, but the statistical analysis mainly with the small data or the large data. Interpretability. Statistical analysis provides more interpretable results, as the models are often based on mathematical equations, whereas machine learning models can be more difficult to interpret due to their complexity. So this is a very challenging in case of the machine learning. In conclusion, while both statistical data analysis and machine learning are essential tools for extracting insight from data, they differ significantly in their underlying philosophies, methodologies, and applications. Statistical analysis provides a more traditional hypothesis driven approach, whereas machine learning offers a more flexible algorithmic approach to data analysis. By understanding the strengths and limitations of each approach, researchers and practitioners can choose the most suitable method for their specific data analysis needs. In the context of machine learning, without being explicitly programmed means that the algorithm or model is not given a set of predefined rules or instructions to solve a specific problem. Instead, the algorithm is designed to learn from the data itself by identifying patterns, relationships, and trends within the data. This learning process is typically achieved through various machine learning techniques such as self-supervised learning. The algorithm learns from the data without any human provided labels or annotations. Unsupervised learning. The algorithm discovers hidden patterns or structures in the data without any prior knowledge of the expected output. Reinforcement learning. The algorithm learns through trial and error, receiving feedback in the form of rewards or penalties for its actions. Now, when you are dealing with the ChatGPT, you have noticed that sometimes ChatGPT is asking you the question by giving two answers and telling you that which answer you like most. So this is the reinforcement learning. In each of these cases, the algorithm is not explicitly programmed to perform a specific task. Rather, it learns to perform the task through its interactions with the data and the environment. To illustrate this concept, consider a simple example. Explicit programming. A programmer writes a set of rules to sort a list of numbers in ascending order. The program follows these rules to produce the sorted list. But a machine learning algorithm is trained on a data set of numbers and it learns to recognize patterns in the data. Through this learning process, the algorithm develops the ability to sort new, unseen list of numbers in ascending order without being explicitly programmed to do so. In the context of machine learning, without being explicitly programmed, means that the algorithm or model is not given a set of predefined rules or instructions to solve a specific problem. Instead, the algorithm is designed to learn from the data itself by identifying patterns, relationships, and trends within the data. This learning process is typically achieved through various machine learning techniques, such as self-supervised learning. The algorithm learns from the data without any human provided labels or annotations. This is a very interesting point, wherein you can understand the difference between machine learning and the statistical data analysis. In statistical data analysis, you are assigning the classification, you are assigning the labels. But in case of the machine learning, you are not assigning any labels. Machine itself is able to label. Unsupervised learning, the algorithm discovers hidden patterns or structures in the data without any prior knowledge of the expected output. Reinforcement learning, the algorithms learns through the trial and error, receiving feedback in the form of rewards or penalties for its actions. In each of these cases, the algorithm is not explicitly programmed to perform a specific task. Rather, it learns to perform the task through its interactions with the data and the environment. To illustrate this concept, consider a simple example. Oh, I have already discussed. There are 5 quizzes based on the provided text. Quiz 1. What is the primary objective of statistical data analysis? 4 options are there: to develop predictive model, to identify patterns and relationships within a data set, to visualize data, to perform hypothesis testing. So what is the primary objective? Primary objective will be to identify patterns and relationships within the data set. Now, another question is, which of the following is a characteristic of machine learning? 4 options are there. It relies heavily on probability theory and mathematical modeling. It assumes a underlying distribution of the data. It makes minimal assumptions about the data distribution. It is only suitable for small data sets. So now it is very clear that minimal assumption is there. It has no such assumption about the normal distribution. So minimal assumptions are there. Next question, what is the key difference between statistical data analysis and machine learning? Goal, Statistical data analysis aims to identify patterns while machine learning focuses on developing predictive models. That is true. Methodology. Statistical analysis relies on mathematical modeling, while machine learning employs algorithm approaches. That is also true. Assumption. Statistical analysis assumes an underlying distribution, while machine learning makes minimal assumption. That is also true. That means all the answers are correct. Question number 4. Which machine learning technique involves learning from data without human provided labels or annotations? Supervised learning, unsupervised, self-supervised reinforcement learning. Just now we have read that is the self-supervised learning. For that reason, machine learning is different from the statistical data analysis. Quiz 5. What is the advantage of machine learning over statistical data analysis in terms of scalability? Machine learning is better suited for small data sets. No. Machine learning is better suited for handling large complex data sets. Yes, that is true. Statistical analysis is better suited for handling large complex database. No. Both machine learning and statistical analysis have the same scalability. No. So the correct answer will be the machine learning is better suited for handling large and complex data set. So dear students, now if you have any question, you can ask me. Otherwise, I will close the session. Dear students, do you have any question? So you have
So
understood.
I had a doubt in the uh, machine learning introduction where the third point, model evaluation and hyperparameter tuning. Could you please explain that point again?
Which one, Shara?
So third point in machine learning, model evaluation and hyperparameter tuning. I did not understand the hyperparameter tuning part in the very beginning.
Yeah, that is true. Because in case of the machine learning, you are dealing with the training and the testing. Okay. Therefore, uh, initially you have to use the large data set for the development of algorithm. Okay, for the development of the algorithm. And next, you have to use the result for the testing group, wherein you can test whether your model is correct or not. So this is the model evaluation. And hyperparameter tuning, that is if you find out that is the discriminant function that is not working, okay, then machine will be able itself to tuning the discriminant function. So it is the self-supervised learning. Usually, what the researcher will do, researcher will think about all the options, and researcher will give all the options to the machine. So there will be no explicitly programmed. For example, when you apply uh, the washing machine, when you are uh, using the washing machine, then by the machine is collecting the data about the texture of your cloth. And machine is collecting the impure and the pure. So machine is able to classify. This is the impure condition texture and this is the pure texture. Okay. Now machine itself is able to change the flow of water following the algorithm given by the researcher. Okay. So machine is able to do when the data are very complex in nature. So it will not be explicitly programmed. So if you find that is the pure texture and the impure texture, and the difference is high, then certain pattern of water flow will be there inside the tub. So the machine is following fuzzy mathematics here. Now it is clear?
Yes, sir. Thank you so much.
Thank you, Shara. Mr. Jana, any question?
No, sir.
Okay, thank you, everybody. Please you read the note and also the quizzes. If you have any question, you can ask me in the WhatsApp group, no problem. And I will assign some of the question to you. Please you answer. Okay, Fada. So I'm closing.